Okay, so there are a lot of standard modules in Python. I think you all know that by now. These are easy to access, particularly, we're concentrating on Python 3 here. You simply use import. We've already talked about that syntax and used it, actually. Uh, there are also advanced and specialized modules. These are not part of this so-called standard library, and you may have to first install a new package to your server or computer first. This you may have heard about or even used, of course, like Pandas, NumPy, Matplotlib, scikit-learn, etc., etc. Those are actually the four we are going to focus on in class. Um, you can also make your own modules. We've actually already done that in class, and we reviewed that in the first part of the notes. So this is kind of where I want us to be right now within the class. We're just now, we're going to start making use of these other resources. Okay, so some important modules that are out there that you're going to most likely need to use at some point in your life. These can be imported using any standard Python install statement. Just install random, install CSV, install statistics, install math. We've actually used math, I think, and maybe random. I can't remember. Here's an example. Oh, this is why I thought random, because this was code I wrote fairly recently. We have the module random. Then we're going to make a reference to the function random, not confusing at all, right? Where we're going to save the result of just a random generation of a number within the object rFloat, and then print it. So go ahead and type that in, make sure you can get a value. I have no idea what you're going to get since this is a random generation. Another thing we could do is random, then using the function randint, and this is going to create a random integer between 0 and 11. Also type that in, see what you get back. Notice the syntax. The module, random, is on the left-hand side, then period, the function name. But we already know that. This is review. We could also do statistics. Type. These are very easy statistics. Import statistics. Here's a list of numbers, right? So that's saved in A. So statistics.mean, statistics.median, statistics.mode, standard deviation, variance. Nothing too surprising here. Just make sure that you get, that you're getting results here. Okay. We're gonna, oh, I have a typo in here. I just saw. That's okay. Here's some important packages for using data within Python. I should have not written modules, but instead packages here. I just saw the typo. These are the ones we're going to focus on. I think these are really, really useful. I actually have maybe I should make a video of it. We'll see. I have a whole module set up around Matplotlib to show you some neat plotting functions and some cool ways you can really control the graphical parameters to make effective visualizations of your data. With any of these packages, remember a package is a set of modules, a directory of modules that you can have access to, all of the components of those modules, the functions, the data, etc., etc. You simply need to use the pip command to install these. So pip install whatever package. So NumPy, Pandas, Matplotlib, blah, blah, blah. Okay. Easy enough. Again, you can Google this and very quickly find recommendations on what to use for what. That's not my objective because I think that's actually relatively easy to do, but instead to provide you examples and learning experiences to get some experience using these, since I am not a fortune teller and will not know what's going to be most important to your research in the future. it's customary to, when you import some sort of module or package, to call it a short name, and that just saves typing. I really like doing that. Like I've already told you, I err on the side of maybe being a little lazy when I'm writing my code, because I'll sometimes forget to write enough comments. And then there's a fine line between having a name for a variable that helps you remember what in the world it is, and it being too verbose. But the nice thing about these shorthands is you just use the same one all the time. So you know PD is Pandas, you know NP is NumPy. It's very easy that way. All right, so states data. We're gonna, the read underscore CSV function right here is from Pandas. It's going to read in that states data. I'll make sure and include that on our module in the online version of the course. Then we can look at the head and the tail. Easy enough. Just make sure you can get this to run. It's comma delimited data, so you have to add the delimiter option. This looks just like R though. In fact, the only difference is instead of a period, you have an underscore. It's no difference. Oh, whoops. I should not have that there. I was copying LaTeX pages. We can do all kinds of things also to extract columns. I think this is really important. I know with me, when I'm using big data where I have hundreds and hundreds of variables, I often will create subsets of them just for ease and make it more accessible. So for example, if I want to extract the variable, this is a variable name unemployment, like it's percentage unemployment, I think in the states data. The percentage who belonged to a union, the percentage who attended something. I can simply create it like a list. So notice this is a list of character strings. Now we know what this is. That's why I wanted to start with lists, so that we know what's happening here. And then the brackets, of course, are our operator within Python that gives us the ability to subset. Okay. Now, if you only need to do this for one variable, you can simply do this. So states dot the variable name. So if you just want to say plot that one variable or get the mean for that one variable, this is probably the easier way to do it. But multiple variables, this is the better way by far. If we want to filter the variables in some way, like for, logically subset the data set so that we just get the unemployment percentage being bigger than 4% and take a look and run our analysis just on that subset of the data, we can do things like this. So notice how easy this is. We don't even have to remember the commas like you do in R, right? You take state stat, and then our logical statement here is wherever state stat unemployment variable is bigger than 4. And I would save this as a new object. I don't have that assignment operator in the notes here, but I would save that as a new object, and then you've got your subset of the data that's filtered according to some criterion. We could also subset according to a categorical variable this way. So we had regions, so southern states, those that are categorized as being from the south, we could save them in that way. Take a look, make sure you can get these to run. So how could we combine subsetting and functions? It's not so hard. Just do the following. So a function like head. If I only want to see the first few observations where the state's unemployment rate is bigger than 4%, I simply do this. Or, and this is kind of interesting, and I still am not entirely used to this, given I spent so many years as an R programmer. We could move the function over here. So you can do the function first and then filter, or you can filter first and then apply function. Now, of course, our function could be something more complicated than head, like we could put mean in. or maximum or variance, for example. Okay, so that gave you a little taste of working with some of these packages and modules within Python. For the rest of the course, we're going to get more applied and less kind of programmy, so that we can spend more time exploring some of these options.